Welcome back, guys. And in this video, we're going to be going over coding our objects. This will probably be the most intense video. I've got to type some code here. I'm going to try and talk about what the code is and why I'm typing it the way I am and how it works. I might be switching over to the Blackboard just to kind of give like an explanation of the logic and why we're doing things the way we're doing them. And yeah, it will involve quite a bit of typing. So just be ready. And as I'm typing, if I'm typing too fast or if you can't follow, and I assume most of you won't be able to follow because you don't have double screens and you have to be swapping between your GameMaker and also my video, just go ahead and pause the video and then look at what the code is and then copy it over, okay? So let's get started. I'm going to start with the easier object. So for example, the wall. We know from the very first class that the wall doesn't do anything. All it has to do is bounce the ball off of it. So there's no code involved, no events, nothing like that. Because we are using the physics system in GameMaker Studio, we do have to tell objects to use the physics system as well. So I'm going to click on uses physics. Whenever you click uses physics on something, next thing is you have to go and configure the physics settings of it. So let's click to physics. And every object that is in the physics system has these special values. So density is how much stuff or how much mass is in something. If you guys have taken physics, you will know that this is kind of like how heavy something is. Heaviness is kind of the wrong term because heaviness has to do with gravity, but density is how much stuff is in something. So the denser something is, the harder it is for it to move. The lighter it is, the easier it is to move. The one exception is if you set its value to 0. If you set the value of something to 0, then it becomes infinitely dense, which means it will not move. So these are the walls, we don't want them to move, so we set their density to 0. Restitution is how bouncy something is. The walls are not bouncing off of anything. First of all, they're not even moving. So we're going to set this value to 0 as well. Collision groups. So collision groups, you can kind of set up, if you had lots of different things in your game and you only wanted some things to collide with some other things, then you can set up special collision groups that they are part of. Now, when I was reading through the documentation of GameMaker, I found that they don't recommend using collision groups because they're very expensive computationally. That means the processor has to do a lot of work to make collision groups work properly. So what they recommend is we set collision group to 0, which means everything is going to be in the default collision group. Next part is linear dampening. So this is once again, if this object was moving through space, then in a straight line, how much does it slow down every step? So I'm just going to set that to 0. It's irrelevant for us. Angular dampening, if this thing was rotating in space, then how much does it start slowing down the rotation? I also need to set that to 0 because this does not move. And friction, if there was a character or something on this wall moving across it, then friction could be applied, but there isn't. It's just a ball bouncing off of it, so we can set literally everything to 0. So that's that part. And then everything, as I mentioned earlier, every object that uses the physics has to have a physics fixture. And you can modify that by clicking this modify collision shape. There's our sprite. So the sprite is a little image in the middle. If I zoom in, I can kind of see that I've got a box that surrounds it. So the physics shape for this sprite is a box, which is perfect because that's what I want. So I can close this, and with that, the wall is configured. So my wall is ready to go. I can place it in my rooms, which will be in the next video. Next one I need is the block. So block is fairly simple too, so let's just take care of it. So same thing, the block is going to be using physics. It's because it's using physics, we need to go and modify its physics settings. The blocks do not move. The only thing they do is they get destroyed. So we can set their density to 0. They don't bounce. They don't have a collision group. Because they don't move, you can set these all to 0. And they also don't have friction. We don't want the blocks to be slowing down the ball as the ball hits them. Okay, so that's everything like that. Once again, we do need to set up a physics fixture. So we need to click modify collision shape. We're going to zoom in and just double check that it's perfect. So we once again have a box or a rectangle and it's on the outside corners of the image. So perfect. this guy is all set and to go for physics. Now, if we think back to the very first day, the block did have some logic in it. The logic was that when the ball hits the block, it gets destroyed. So let me show you how that's done. So we go add event, collision, objects, and we find the object that's going to be colliding with it. So when this block has a collision event with a ball, so that means the ball has hit it. Either the block has hit the ball or the ball has hit the block. It's kind of the same thing. Because of we want the responsibility of this action to be part of the block, not the ball. The ball doesn't really care about the blocks. It's the blocks that care about being hit. And for the event in here, for the action. So this is the event. This is what happens. So the ball hits the block. How to respond? And the way we're going to respond is to type some code, and the code is instance_destroy. Instance destroy takes a current block that's in the game that was just hit, and it destroys it, makes it disappear from the game. This is called an instance function. Anything that's orange in GameMaker is a function, which means it does something for you. And the way you find out what these do is you can middle click them with the mouse if you'd like. So I just did a middle click and it opened up this manual for me. And you can read this in thorough detail. It tells you how to use it, how it works, and so on. Some cool thing to note is if you do open up the GameMaker Studio 2 manual, and for example, I clicked on instances. Instances are what we place into our room, all the objects. You'll notice that there's a big list of functions. Instance destroy is on this list, but there's also other functions. So I don't know all these things off by heart. I didn't come to just magically know what to type. I actually spent hours and hours, hundreds of hours actually, going through this GameMaker Studio 2 manual, and I learned all the different functions that are available to me. And that's how you do it. Especially when you're new to a system, it's a very good idea to have the manual open on a different monitor or screen, and just be able to read through and figure out what functions are available to you. That's how you learn systems like this. But anyways, that's all we need. When the ball hits the block calls instance destroy on itself, and it gets removed from the game. Okay, so that's the code for the block. Now let's move on to something still relatively simple. Let's do the paddle. So our paddle is also a physics object, right? So it's going to be controlled by physics. So we need to go over to physics. So here's the interesting thing. The paddle does move around. So the question is, do we give it density? Well, no. We're going to set it to 0. We're going to set all these things to 0, actually. Because the paddle does not move around based on physics. The paddle moves around based on some logic that we're going to type in. And the specific logic is when I move my mouse, the paddle moves to it. So when you think about that, you realize that it's not the physics system that's moving the paddle. It's actually the player that's moving the paddle. And when that's the case, you need to make sure that physics object is kind of like has all these things zeroed down if that's what it needs, but it also needs to be kinematic. A kinematic physics object, and this works through all game engines, so it doesn't matter if you're using Unity or Unreal Engine or GameMaker Studio or anything else. The term is called kinematic, and all that's saying is that this object is actually not controlled by the physics engine. It's controlled by some kind of logic that the programmer has put in. So the paddle is going to be controlled by us, so it's going to be a kinematic object. The reason it's still a physics object is because it does impact other physics objects, for example, the ball. We do need to modify the collision shape for it. So if I zoom in, we can see that this is not what we want. Also, when I move the screen, kind of like this, all I'm doing is I'm pressing the middle mouse button. So my mouse wheel, I'm pushing that down, and that's how I'm moving the image or the screen. And it works in any part of GameMaker. If you guys are using your mouse, like a mouse pad that's on your laptop, this won't work. It'll be very difficult to use that. So I highly recommend you guys have a mouse for GameMaker Studio, especially a mouse with a middle mouse button. Okay, so we need to modify this shape. We can't use a box, so I'm going to switch this to a convex shape. And then we need to add points to it. I like to turn on the grid. I like to set the grid to a 1x1 grid, so that makes it a very small grid. So that means I can be very precise on where I want to put these. I'm just going to put these dots kind of like where I think it makes sense. So of course I want to go in the corner. Kind of like that. So all I've done is I've added some dots. I might want to go on the outside here. Actually, I forgot to do this. So if you turn on snap to grid, it'll help you place these on actual proper points in the grid. So let's redo all of them. So that's in the corner, that's good. That's in the corner, perfect. Oops, where'd it go? This is another useful button. This for edged box. When you click it, it brings your image to the middle of the screen. So, and I'm zooming in, so I'm holding down the control key on my keyboard and rolling my mouse wheel forward, and that helps me zoom in. Put this one here. Put that one there. This one there. And this one here. Perfect. So I've got a perfect convex shape that now surrounds my paddle. And now, so when the ball comes down here, it's not going to hit a flat surface, it's going to hit an angled surface, and it's going to bounce off at some angle. That's exactly what we want. Okay, so that's it for the physics. Oops, where'd it go? Here's my paddle. Also, when you lose something, so I just lost the object, you can double click the resource again, and it'll come back to view. So we're done with the physics side. Now we need to do some coding. So first question is, when does this paddle have to move to the left and right? So like, does it move once a second? Does it move when you move the mouse? Like, when does it move? And the answer is actually it moves every single frame. So the games are running at 60 frames a second, so it's running very, very quickly. And whenever the mouse will move at some point during those frames, so we don't know which exactly those frames are. We just have to assume that it could move at any frame. So the way we deal with that is we respond to every single frame. And the way you respond, or you run code during every single frame in GameMaker, is you respond to what's called the step event. So we go down to step and step. So this event here, it's not like a collision event, which only happens when two things hit. The step event happens every single frame. So this event is called every single second, 60 times a second. And what we need to do with this paddle is we have to modify its horizontal position. We need to move it left and right based on where the mouse is. So the way we do that is because we're using the physics system, you have to use the physics variables. If you type in PHY, it brings up a big list of physics variables that we can modify. And the one I want to modify is position. So physics position X. Okay, so that's the horizontal position of the paddle in the physics world. I'm going to click equals. And I'm going to set it to be mouse X. So mouse X is the horizontal position of the mouse on the computer screen. Now, when I was talking about the logic for the paddle, I did mention that the paddle should not go off screen, so it shouldn't slide off the screen. So how can we make sure that it stays, so it doesn't go off the screen? Well, what we can do is use a math function. So I'm just adding a math function before here. It's called the clamp function. What clamp does is you pass it a value. So the value in this case is my mouse position. And then I set a minimum and maximum value. So if the mouse position ever goes smaller than the minimum value or bigger than the maximum value, then this function will clamp it or pull it back to these values. So if my minimum value is set to be 10 and the mouse is at position 1, then this function will actually return a value of 10 instead of what the actual mouse value is. It's just a way to clamp things. Or if my mouse is, way off the screen at 2000 pixels or something, but my maximum is set to be 100, then this function would instead return 100 and set the physics position X of this paddle to be 100 instead of 2000. So the values I want. So what are the values? Well, we have to think a little bit about this. we've got our walls. Just gonna actually click here. So my wall is 16 pixels wide. Okay, so if my wall's at the edge of the screen, I know that I have to be at least 16 pixels off the edge of the screen. But I also need to consider how wide my paddle is. So my paddle is 96 pixels wide. If I take 96 and split it in two, because I want to split it down the middle, I've got 48 pixels. So my paddle's center should be at least 48 pixels from the side of the screen. But we also have the wall, so we have to add 48 plus the 16 pixels of the wall. So my minimum should be 48 plus 16. So you can type it as 48 plus 16, or you can simply type it as 64, which is the sum of the two. And on the other side, so that's the minimum, so that's the left-hand side. What about the right-hand side? Well, the right-hand side, the position needs to be at the very edge of the screen. So to get the edge of the screen, you can go room width. So that's the whole width of the room. We know exactly it's 800 because that's what we set it to in the original room setup. But if the room was to change its size, then this will give us the exact size. And then this time we want to be moving to the left, not to the right. So we're going to be subtracting that 64 from it. Okay. So we've got physics position X of the paddle will be set to be in between 64 and room width minus 64 based on the position of the mouse. Okay. And that is all the code we need to do for the paddle. Simple as that. And if you are interested in testing it to actually see if it works, we can now go to our room. Let me just zoom out a little bit. I can grab a paddle object. So it's very important that you grab a paddle object, place it in the room, maybe down here. And if you click the play button, if everything worked out properly, it's on the wrong screen here. So this is what the game looks like. You can see as I pull my paddle or pull my mouse left and right, the paddle follows perfectly. And you can see it stops at the edge. It doesn't actually get to the edge. That little missing space there, it's not getting to, that'll be the wall. So it'll look good once we add the walls. Okay. So that's how you quickly test if your code has worked, and you can see that it is working. So that is perfect there. We just need two more things to code. So let's move on to let's close the room. Let's go over to the object ball. Okay, so once again, ball is going to be a physics object. Click that, click on the physics. Let me just go over to my cheat sheet here. Okay, so we don't really need to change a lot of things about the ball. Density, usually the density you can leave what the default value is, unless you're making a game where you have like balloons and metal weights and they're the same size and they have to behave differently, then of course you change the density. But this is a single ball. There's nothing really else that it interacts with, so we can just leave that as that. Restitution, so bounciness. How bouncy do we want it to be? Well, we want it to be completely bouncy, 100% bouncy. So whatever velocity it hits the wall with, it needs to bounce back at the exact same velocity. So to do that, we set the restitution to 1. If you set it to a bigger number than 1, it'll always bounce a little bit harder. So if it hits the wall at a speed of 1, it'll maybe bounce back at a speed of 1.5 and so on. So it gets faster and faster each time. If you set it to a smaller value than 1, then it'll slow down every time it hits something. So setting it to 1 basically just means it's going to keep its current speed. Collision group, we do want to set it to 0, just with all the other ones. Linear dampening, so we don't want the ball to slow down. So as time goes on, as it's flying through the space or air, we don't want it to slow down. So we set that to 0. If it starts spinning, we don't want it to stop spinning or slow down and spin. And in friction, the ball doesn't need to have any friction. So we don't want it to lose any velocity anytime it hits something. We just want it to be the same steady speed. So really, we don't change the density. We set the restitution to 1. Everything else is 0. The ball is not kinematic, so the ball is not going to be controlled by us. It's going to be controlled by physics. And then last thing, we need to set the collision shape or the physics fixture for it. Right now it's a box. That's not ideal at all. We don't want a box. We want it to be a circle. So click circle. There we go. It's already detected that this is the edge of the image. So that's the center and this is the radius. So it's going to have a collision mask or a collision fixture of a circle that goes around like that. Okay, so that's good. All set up. And now let's take care of all the different things the ball has to do. So we'll do the easier ones first. Let's see what happens so when it hits something. So you can go add event, collision, object, wall. So when the ball hits the wall, we don't actually have to code anything. So all I'm going to put in here is collision check. Collision check wall. So this is where the collision groups kind of come into play. If I would have put all these objects into collision group 1, then I would not have to do this. I wouldn't have to worry about telling GameMaker to check for a collision between the ball and the wall. But the problem with that is it becomes very expensive, because then you start checking against everything all the time. Which for like a game like this, it really doesn't matter. But for a huge game where you would have millions of objects colliding together, it would make a big difference. So whenever you put something into collision group 1 in the physics system of GameMaker, you have to specifically tell it to look for collisions with other objects. Even if there's nothing that it has to do, just a basic physical collision, you still have to tell it to look for that collision. So that's why we need to add the wall collision into the ball. But for the actual code, there's no code. It's just a comment. Comments are not code. They are just notes for the programmer. Okay, so when the ball hits the wall, that's all that happens. It just hits the wall. When it hits the paddle, same thing. So we're gonna go collision, object, paddle. So when the ball hits the paddle, it just needs to bounce this off. So let's just say collision check paddle. Very good. And then what else? Okay, we can do an easier one. So next one is, before we do anything here, let's move down here. We need to add a variable definition to the ball. Variable definitions are kind of like attributes. So for example, if I was a character in a video game, I would have variables like hair color, eye color, weight, height, size, strength, and so on. These are programmer defined things. Anything we want to add to the object, we can add. There's different types of variables. They don't mean anything to the computer, they mean everything to the programmer. So it's totally up to you what type of variable you add and how you use it, but it should make sense. So the variable that we're going to be using here is, actually I'm going to call it active. What I mean by that is that if the ball is inactive or it's not active, then it's sitting on the paddle. If it's active, then it's moving around, flying around. Okay, it's going to be a Boolean. You guys should all know what Booleans are. You've taken some other coding classes before. Booleans are true or false. By default, the ball is going to have an active state of false. So make sure this is not checked, right? We want it to be blank. So that means the ball is not active. Now, this doesn't mean to the computer that it's not active. It just means that we have a variable that's that's called active and it's set to false. Okay, so now that we have that variable, we can start using it. So let's use it. Okay, so let's go step by step, like what this ball has to do. So we know when it's not active, it needs to stick to the paddle. So we're going to go add an event, step, and step. So why are we putting this in the step event? Well, we know that the paddle can change positions at any time during a step event, right? That's how we set it up. Whenever the mouse moves during the step event, the paddle moves. So if the ball is not active, it also has to move and stick to the paddle. And the way we can pull that off is, we're going to type some code here. We're going to first check, this is a conditional, and we're checking to see if we're not active. So by putting an exclamation mark in front and typing active, we're looking for the false version of this statement. So if this is false, then this conditional will be true. And whatever goes between the brackets, we're going to execute. Another way to write this, I'll just make a note down here for anybody who's curious. We could type if active equals false. So this statement here and this statement here are the exact same. This is just the abbreviated short form version of it. It's good to know these little tricks. It does speed up your coding quite a bit. Okay, so if the ball is not active, it needs to stick to the paddle. So how do we do that? Well, first you have to make sure it doesn't have a physics speed x, so it can't be moving horizontally. It cannot be moving vertically either. And its position, physics position. So its position x needs to be what? Well, it needs to be the same as the paddle. So by typing O paddle, I'm actually referencing this object. So whatever this object is, I now have access to it, and I can take its also take its physics position x. So I'm setting the physics position of the ball to be the physics position of the paddle in the horizontal direction. And in the vertical direction, so physics position y, that's the up and down direction of the ball, or position of the ball. I want it to be simply at the position where we originally placed it. So when you place something in the room, it has a original position, which is called the start position. And that position is our y start and our x start. In this case, we want the y start, which is the vertical position. And once again, all these things that I'm typing here, these all came from the manual. I did some research, read into it, and I found that these variables exist and I can use them. If a variable is blue, that means it's custom made, like we've created it. The computer doesn't know what to do with it. If it's green, it exists in the game and the computer does use it for some kind of process. And if it's red, that means it's a constant. So that means it's either an object or a something that doesn't really do anything. It's just a number or letter or something like that. Okay, so that's the, just gonna get rid of this for a second here. So this is the code for the ball sticking to the paddle. Really, it's not going to stick to the paddle. It's going to stick wherever you place it. So wherever you place it in the world, it's going to stay there, but also move horizontally based on where the paddle is. So what about launching the ball? So to launch the ball, we're going to add another event. I did say we're going to launch it when I click the left mouse button. So I'm going to go down. We've got two sets of buttons here. We've got all these ones that are very easily described, like left down, right down, middle down. You might be tempted to use left down here, which means I clicked down on the left mouse button. But this won't work. These ones here require you to have the mouse hovered over the object. I want one where I don't need the mouse to be hovered over, which are called the global ones. So I'm going to use global left down. And what I need to do here is, first I have to make sure that the ball is not active already. So if the ball is already in play, I don't want to do anything. So the way I do that is I say if not active. So once again, if it's not active, that means the ball is stuck to the paddle. So if the ball is stuck to the paddle, then I do want to give it a vertical speed. So I'm going to say physics speed y, that's the up and down. I'm going to set it to a number. So let's just say, let's call it strength. Okay, so I'm going to call it strength. And then at this point, I've launched the ball, so now it's active. So I want to set the active variable to be true. So if I click this once, when the ball is not doing anything, this would happen. But if I clicked it again, this would no longer happen because this would be true, and this is looking for false, and the two would be in conflict, so this whole code would get skipped over. So this can only happen once on the first initial click. You will notice that there's a little exclamation mark saying variable strength only referenced once. If I ran the game, it would actually crash right now because this variable does not exist. So I need to go back to variable definitions. Need to add a new variable, call it strength, and give it a, sure, real is fine. Real just means it's a decimal number, and I'm going to set its value to be -10. For some reason, GameMaker has flipped the vertical axis upside down, so negative numbers go up, positive numbers go down. Doesn't make a lot of sense, but that's how it is, so we have to stick to it. The reason I made this a variable here is that you can actually come here and change it to be a bigger number or smaller number, depending on how fast you want the game to be. And you can also change this individually in each room now, so maybe as the rooms progress, the ball starts going faster and faster. So there we go. So this is to launch the ball, and then we need one more event, which is, what is it? Oh, if we're outside the room, so let's go add event, other, outside room. So outside room happens when the ball has fallen outside of my room. So what happens when it falls outside the room? That means it's gone through the bottom of the room. That means we should have died. So at this point we can go active equals false. Right, so by active equals false, we're turning the ball off. We're telling it you're no longer flying around the room. So that means as soon as this goes off, now the step event, which has this code, kicks in again. And that means that the ball automatically teleports to the paddle again. And we can also launch it again. So that's good. So we've got active to be false. And then we also need to make sure that we lose a life. So lives minus minus. You can see that lives is green, which means it is a built-in variable. Lives is a unique one. It doesn't actually belong to this object. It belongs to the whole game. Lives and health are like global variables, which you can access from any object at any time. Yeah. So I believe that's it for the ball. We've got the ball doing, sticking to the paddle, launching, having collisions with the paddle, having collisions with the wall, and going outside the room. You may have noticed that there is no collision between the ball and the brick, or the blocks, I mean. And that's because you don't need to double dip on this whole collision system. Because the blocks themselves, that's not the block object has the collision set up with the ball, we don't have to worry about the ball having a collision with the block. It would actually be more expensive computationally because you'd be telling the system to check collisions twice between those two things. And this way also the responsibility of being destroyed is kept in the block. So the ball doesn't really have to worry about the block. And this is especially useful if you have many different types of blocks in the game later on. Okay, so that is that. We're done with the ball. We just have one more object to code. This is our game controller. And the game controller needs to check for two things. First of all, the game controller is not a physics object. It doesn't even have a sprite. It's an invisible object that controls the flow of the game. The two things I wanted to do or three things I wanted to do really. First, I want to make sure it takes you to the game over room when you are out of lives. So how often do you have to check that you're out of lives? Well, you constantly need to check. Every time there's a frame that goes by, you need to check to see how many lives you have. So it's going to be in the step event, which happens once every frame. And we're going to check to see if we're out of lives. So we can go if lives is less than or equal to 0. Then we're going to move to a new room. And that new room is going to be room underscore go to. So these are global functions that you can use to do cool things. So we want to go to room. And the room we want to go to is room game over. This is a room that does not exist yet. Right? You can see that the variable does not exist. That's fine. We will be creating it in the next video. The other thing this guy has to be looking for is to see how many bricks are in the game. So if we're out of bricks, then we also need to move on to the next level. So if this is another cool function we can use, instance number. So instance number, this function will count how many instances of something are still in the room. So if an instance number of object blocks, so we're going to count the number of blocks. So if our number of blocks is less than or equal to 0, so that means we've destroyed every single block in the game, then we're going to room underscore go to next. So it takes us to the next room. Okay, so if we're out of lives, we go to the game over room. If we are out of blocks, we go to the next room because we just won. So that's one thing. Another thing, so I would like this guy to keep track of, to show me the lives I have. So I'm going to go add event, draw, and draw. The draw event lets you draw things onto the screen. So even though this guy does not have a sprite, he's able to draw some things onto the screen. The thing we want to draw onto the screen is something, it's just our lives. So we're going to go with draw. First, we're going to set the color to white. I want to make sure it draws in white color. So draw set color. This function lets you change the color that it uses to draw things onto the screen. So draw set color C white. That's a constant for the color white. And then we're going to draw some text. We're just going to draw it in the X and Y position. So the X and Y position is the position of this object. So wherever you place this object in the room, that's where this is going to be drawn. And then the thing we're drawing is a combination of a string, which is made up of characters plus a number. So to do that, you first do the string. So this part here, this is our string. And then we're going to add something to it. So that's, you can see I've left a little space here. The reason for that is because I'm adding some more stuff to it. And what I'm doing is I'm going to use a function to turn a number into a string, because you cannot combine numbers and strings. You can only combine strings with strings. And I'm going to be taking my lives and turning it into a string. So when that happens, it's going to say lives equals, or lives colon, and then a number. All right, so I think that's it. The last thing we need here is in the variable definitions of our game controller, we're going to use that because the game controller controls our whole game. It makes sense to control how many lives you have as well. So in here, I'm going to say lives. I'm going to set it to 3. Once again, because this is part of the variable definitions, I can change this per level. So if you make a more complicated level, you can give your player more lives to play with, or if it's an easier level, you can take away some lives, and so on. So is that it? That's not it. So we need one last thing. We need to be able to restart the game. So if you're in the game over room, or if you're in the game winning room, so there'll be 2 rooms. One is when you've won, one is where you've where it's game over. Yeah. When you're either in either of those rooms, you need to be able to restart the game. So let's just pick a random key. I'm going to say, sure, mouse button, global left down. Sure, why not? So if our room is equal to our game over, so if we're in the room game over, or if we are in room win, so these are 2 rooms we will have to create later on. So if the room is either game over or it's either room win, then we're going to go game underscore restart. So if you click the left mouse button in either of those rooms, the game will restart and go back to level 1. Okay, I think that's all the code that we need. My one concern is all of this will happen in the final rooms as well. And so that's bad because it'll take me to the next room, for example, from a game over room if there's no blocks in the room. So we have to make sure all of this code in the step event only runs if we are not inside those 2 rooms. So what I can do is go back to my global left down button, select this whole code here, copy it, Control C is copy. Go back to here, press Control V to paste. And I can put these in a bracket and then put an exclamation mark in front. So what I've kind of done is I've told it to negate the question that I asked before. So before, the question I was asking was, am I in the game over room or am I in the winning room? Now I'm saying, when you put the exclamation mark in front with the brackets, it's saying, am I in any room other than game over or win? So it's like the opposite. That means I'm in any other room except for those 2. So if you're in any other room then except for those 2, then you do this code. Okay. And that is it. That was a lot of coding. I'm sorry. A lot of explanation too. But this is how game design works. You break down the objects into smaller parts, smaller problems, and you solve each problem one by one. Okay, so we'll end there. In the next video, we'll put it all together and start building our rooms. Okay, and thank you for watching.